Hello, my name is Dmitry Kovaisky from Intel, and I would like to present a demo on gramine TDX, a lightweight OS kernel for confidential virtual machines. This is a joint work with our collaborators from Intel. Virtualization-based confidential computing technologies, such as Intel TDX, allow to transform entire virtual machines into secure and isolated confidential virtual machines, or CVMs. Such CVMs are typically deployed with a Linux kernel as their guest OS. However, the Linux kernel was designed to trust the host system and the underlying hardware, which contradicts the threat model of CVMs. Recent attacks such as Hackler demonstrate that this trust assumption is inadequate and can easily break security guarantees of confidential VMs. Ultimately, gaining some level of confidence in a CVM with Linux as a guest kernel requires a significant manual effort to harden the whole Linux codebase. In our work, we propose an alternative solution, the Gramine TDX library OS that runs as a guest kernel inside the CVM. Gramine TDX is a single-purpose and security-first kernel that is slim. For example, it is 50 times less in binary size than a typical server-grade Linux kernel in Debian. Gramine TDX has a minimal hardened attack surface and is built on a decade-long expertise with Intel SGX. Many lessons learned from and techniques used in SGX development can be directly applied to Intel TDX. In particular, Gramine TDX reuses many features already existing in Gramine, which was originally developed for Intel SGX environments. Some examples: we reuse the Gramine manifest file for security configuration of a target application. We reuse the two-way sandbox, which implies system call filtering in one direction and system call validation in another direction. We also reuse transparently encrypted files and integrity-protected files. For remote attestation, we reuse the array TLS solution, which adds remote attestation flows to classic TLS sessions. Finally, we provide Docker container integration with the same tooling originally developed for Gramine SGX. Gramine is a specialized solution for applications that must run with a minimal trusted computing base, TCB, without any modifications. Originally developed for SGX, Gramine provided more features but enlarged TCB in comparison to other SGX runtimes. In contrast, the newly developed TDX backend for Gramine provides less features but a reduced TCB and thus stricter security guarantees in comparison to other TDX kernels like Linux. Please check out our poster for more details on the design and implementation of Gramine TDX. Right now, let's jump to the demo.
In this demo, I will run a PyTorch AI ML benchmark, the AlexNet image recognition neural network. As an input, I will feed an image of a Labrador retriever, and the benchmark will perform 1000 inferences on this input. 1000 iterations are simply for benchmarking the runtime. First, I run the native original version of this workload. As you see, I run it on 4 CPU cores, and PyTorch spawns 4 threads correspondingly. The PyTorch application correctly identifies this dog as a Labrador retriever. Then, for comparison, I run the Intel SGX version of this workload with Gramine. This is the existing SGX backend. It creates an Intel SGX enclave in which the PyTorch application is executed, thus providing a high level of security to the application. It takes some time to start up because to run this workload, I need to carve out 8 GB of enclave memory. So you see that it also runs it on 4 CPU cores. As you can see, it outputs the exact same result as the native version, with a runtime overhead, excluding the startup time, of about 20%. Finally, I will run the Intel TDX version of this workload with Gramine. This is our new Gramine backend. It creates an Intel TDX virtual machine in which the PyTorch application is executed, with Gramine serving as the OS kernel, providing a high level of security and protection to the application. Similar to SGX, it takes time to start up. We need to create an 8 GB sized virtual machine, and we need to mark all its memory as TD private. The virtual machine is started with 4 virtual CPU cores. And now, as you can see, the output is exactly the same as in the native version, with a runtime overhead, again excluding the startup time, of roughly 10%.